All right, so our last new topic when we're looking at multi-units is looking at what we call recycle and bypass. And these are two very, very critical types of ways of manipulating flows, especially as environmental engineers. So in general, it's rare that the chemical reaction, say A to B, is going to proceed to completion in a reactor. There's going to be things that are produced as byproducts, or we're not going to have 100% pure B coming out of the reactor. So as a result, some of A can normally be found in the product stream, and any A that's leaving in the product normally represents what we would call wasted resources. So one possible solution to this, to try not to waste resources, is recycling. So you may have heard of this. And basically the method is that you're going to bring any of that unused reactant A back to the beginning of the reactor and try and use it again. So this is going to be very common in wastewater treatment for recycled sludge. We see this quite often as environmental engineers recycling components to maybe get a better product at the end. So the benefits are going to be that we purchase less reactant chemicals, so we're not spending a ton of money or wasting extra chemical. But some of the drawbacks is that the cost of the equipment to perform that recycle can be costly as a capital investment. So in general, when it comes to recycle, what we need to know is that recycle basically takes a line out of something like a separator or a reactor, and it brings it back and ends up creating a mixing point up ahead of where it started. So a recycle is always coming from the right side of the flow diagram back to the left and creating a new mixing point. So this is just a general example where we have something coming into a reactor, a certain amount coming in, and then we have a separator that does its best to separate A and B, but doesn't really succeed. So it recycles some of that stream so that we can try again and basically get a better product on the outside. The other component that we see quite often as environmental engineers is bypass. And this is the procedure by which a fraction of the feed to a process is diverted around the unit and combined with an output stream from the units. So why would we need to bypass a unit? Well, in some cases, a specific chemical in a stream may hinder downstream chemical reactions. So we want that chemical to go around a reactor so that it's not catalyzing or hindering any reactions in the reactor. We might want to reduce the mass flow or the volumetric flow through the unit. So maybe our water treatment, for example, can only handle a certain flow rate. And so the flow rate might be too high and not everything needs to be treated. So we can bypass part of that flow around the unit to make sure that unit operates the way it's supposed to. We can also do this to keep a consistent concentration of a substance in the input feed to a unit. So if we have high variability in our flow and we're trying to get a very specific concentration, we might want to bypass a certain amount around to maintain that concentration. And so a generic bypass unit is the exact opposite of a recycle unit. There is a split point coming into the feed, and the bypass stream goes around the process unit and creates a mixing point downstream. So instead of going right to left, which is recycle, this one goes left to right, and that's a bypass line. And that's it in terms of what's going on with recycle and bypass. In the next videos, we'll see an example of a recycle using an air conditioner.